All right, let's talk about something we all just take for granted. How does the internet actually keep a secret? I mean, think about it. You're sending your most private info across this massive global network, and you just kind of trust it'll get there safely. Well, today, we're going to pull back the curtain on how all that security actually works.
So let's make this super real. You're online, you found something you want to buy, you hit the checkout, and you start typing in your credit card number. Now, how is it that a hacker who could be sitting right next to you at a coffee shop on the same Wi-Fi can't just snatch that number right out of the air? That's the big question.
You know, to really get the solution, we first have to understand the original problem. And it all starts with the basic language of the web, HTTP. It's the foundation of everything, but it has one giant flaw.
And this is the perfect way to think about it. Sending data with regular old HTTPs is exactly like sending a postcard through the mail. Your message, whether it's a password, a search query, anything, it's just written in plain text for literally anyone who handles it along the way to see.
And that postcard problem opens the door to what's called a man-in-the-middle attack. It's pretty much what it sounds like. An attacker puts themselves between you and the website you're talking to and just listens. They read everything. And this is scary easy to do on public Wi-Fi, which makes that whole postcard thing a very, very real risk. So, if HTTP is an open postcard, what's the fix? Well, it's actually pretty intuitive, right? You put the message in a sealed envelope. And that, right there, is HTTPS. That little S at the end stands for secure.
And this slide really lays it all out. With HTTP, your data is just out there, totally exposed. But with HTTPS, it's scrambled into complete gibberish before it even leaves your computer. So yeah, a hacker might be able to grab the envelope, but they have no way of reading what's inside. And you can actually see this in your browser. It's that little padlock icon you see in the address bar.
So what's the glue that's sealing this digital envelope? You've probably heard a few different acronyms thrown around. Let's clear up what's actually protecting you right now.
Okay, here's the deal. SSL was the original. It was a game changer back in the day, but now it's completely outdated and insecure. The thing that protects you on pretty much every secure website today is TLS. It's way faster, it's stronger, and it's just better in every single way. And here's a little quirk you'll notice. People, and even a lot of companies, still say SSL certificate all the time. It's really just an old habit. The name stuck around, but the tech doing the actual work, the thing keeping you safe, is almost definitely modern TLS.
Okay, so your browser and a website server want to start talking securely with TLS. How did they even begin? They can't just start firing encrypted data at each other. Before they can share any secrets, they have to secretly agree on the rules for the conversation, and this all happens with a process called the TLS Handshake.
And this whole dance happens in the blink of an eye. Seriously, milliseconds. Your browser says, hey, let's talk securely. The server shows its ID. That's the TLS certificate. Your browser then checks that ID to make absolutely sure it's talking to the real website and not some imposter. Once that's all verified, they get ready for the final and most amazing step, creating a shared secret key. And this brings us to the most brilliant part of this whole thing, the part that, honestly, feels a little bit like a magic trick. How do two computers in public create the exact same secret key to lock and unlock their messages?
I mean, really think about that for a second. If you send the key over the internet, a hacker can just grab it, right? So you can't send the key, but somehow both your browser and the server need to have the exact same key. How is that even possible? Well, the answer is some seriously clever math.
The whole process kicks off with a couple of numbers that are completely public. Think of it like a shared recipe. The server just puts them out there for anyone to see. Your browser, the server, and yeah, even a hacker listening in. By themselves, these numbers mean nothing. So here's where the magic happens. Both your browser and the server, at the same time, secretly pick a private number, a secret ingredient that they never, ever share with anyone. Then they each take their own secret number, mix it with those public ingredients, and create a new public number that they exchange openly. A hacker can see those numbers being swapped. But here's the trick. Each side then takes the public number they just got from the other and mixes it one last time with their own original secret number. And because of how the math works, boom. They both, totally independently, arrive at the exact same final number. That number becomes their shared secret key for the entire conversation. It was never actually sent across the internet. It was created on both ends at the same time. Let that sink in. The key was never transmitted. It never existed on the network, yet both sides have it.
The hacker saw the public recipe and the mixed results, but without knowing those initial, private, secret numbers, it is mathematically impossible for them to figure out that final, shared key.
And when I say impossible, I mean it. In a real TLS handshake, we're talking about numbers that are huge, often 4096 bits long. There just isn't a computer on Earth that has enough power to guess and check its way to the answer in any realistic amount of time. That's the power of modern encryption.
So HTTPS, powered by TLS and this incredible key exchange, builds us a private, secure tunnel right through the middle of the wide-open internet. But, technology never stops moving. As our computers get faster, especially with things like quantum computing on the horizon, the unbreakable codes of today could someday become breakable, which leaves us with one last question to chew on. What comes next in this endless race to keep our digital lives secret?